Alright, so we're going to look at a couple more ways to factor polynomials today. We're going to look at factoring by grouping. And we're also going to do factoring using quadratic form. So first, factoring by grouping. This is whenever we group pairs that have a common monomial factor. Okay, so group pairs that have a common monomial. Alright, so here we see RA and RB. So A and B have R in common. So I can say that RA plus RB is the same thing as R times A plus B. Alright, now that is added to these two are both being multiplied by S, so I can factor an S out of them. So S times A plus B. So here we have both the R and the S are being multiplied by A plus B. So I can actually take the things that are outside and group them together, and I can say this is the same as R plus S times A plus B. Alright, and let's see why that works. Okay, if we're using distribution, we have R times A and R times B. If we were foiling down here, we'd say R times A plus R times B plus S times A, plus S times B, S times A, S times B. Alright, let's try it out. I'm going to group for x cubed minus 3x squared minus 16x plus 48. I'm going to group these two things together, and I'm going to group these two things together. So, what do x cubed and negative 3x squared have in common? How many x's? X squared. So they have x squared in common, and then left over I have an x minus 3. So now my goal, whenever I find the common factor between these things, is that I need to have an x minus 3. So, what do negative 16x and positive 48 have in common? Negative 16 goes into 48. So I can factor out a negative 16. And if this is negative, it's almost always you factor out a negative. So, minus 16, and left over I have an x. Now, 48 divided by negative 16 is negative 3. Alright, since we have x squared times x minus 3 and negative 16 times x minus 3, I can group these as x squared minus 16 times x minus 3. Alright, but whenever we did this, we see x squared minus 16. X squared minus 16 is the difference of two squares, right? So this can still be factored. If I see a squared, I have to think, can I still factor it? Alright, and how do we factor x squared minus 16? X plus 4, x minus 4. So this breaks down to x plus 4 times x minus 4 times x minus 3. That's completely factored. Alright, looking at this next example, 27t cubed plus 45t squared minus 3t minus 5. So 27 and 45, what number do they have in common? What number goes into both? 9. So I can pull out a 9. How many t's can I pull out of these two? Okay, so t squared. So 27 divided by 9 is 3. And t cubed divided by t squared is t. And then the t squared is going to cancel off the 45, so 45 divided by 9 is 5. Okay. Now for this next group, negative 3t minus 5, the only thing that they have in common is that they're both negative, right? So I can pull out a negative 1, and that would leave me with 3t plus 5. Which is exactly what I needed to do because I saw this 3t plus 5 and I knew that this needed to be 3t plus 5. So now I have 9t squared minus 1 times 3t plus 5. Because the outside things came together to be 9t squared minus 1. Now, I see a squared, so I have to say, can I still factor this? 1 is a perfect square. What about 9t squared? Is that a perfect square? Yeah, from 3t times 3t. So this breaks down even further to 3t plus 1 times 3t minus 1. And that's from difference of squares. So we'll make a little note, just like last time. Difference of squares times 3t plus 5, because it's still hanging out. So now this is completely factored. Alright, the last example, x cubed plus 7x squared minus 9x minus 63. X cubed and 7x squared, what's the only thing that they have in common? X squared. So I'm left with x plus 7. Okay, negative 9x minus 63. Negative 9. And I know that it needs to be negative because I want to be left with just one positive x, right? And negative 63 divided by negative 9 is positive 7. So now I've got my outsides. And inside the parentheses I have the same thing. So I'm left with x squared minus 9 times x plus 7. Now were we done? No, because of what? I've got a difference of two squares, x squared minus 9. What does that factor to? X plus 3 times x minus 3 times x plus 7. Okay, the other type of factoring that we're going to talk about is quadratic form. And so the technical version of this is anything of the form au squared plus bu plus c, and u is any expression of x. So like, this is what that means. If I'm looking at x to the fourth minus 14x squared plus 45, I can rewrite this in a quadratic model, okay? What if I just said, okay, x to the fourth, that's just x squared squared minus 14x squared plus 45. Okay, so what this quadratic form means is that if you were to replace these x squareds with u's, well then it would just look like a normal quadratic, right? You'd have u squared minus 14u plus 45. But we're not going to replace with u's and all that stuff. All we have to do is factor this like normal, okay? And then instead of writing an x, we're dealing with x squareds that are being squared. Okay? So just looking at this like a normal thing, what two numbers multiply to positive 45 and add to negative 14?
7.
No. 9 and 5, right? And they must both be negative. Negative 9, negative 5. So whereas with a quadratic we would have written x minus 9, x minus 5, now we're going to write x squared minus 9, x squared minus 5. Alright, now let's pause and let's think, if I were to FOIL this out, would I get this back again? What's x squared times x squared? X to the fourth. And look, x squared times negative 5 is negative 5x squared, plus negative 9x squared would be negative 14x squared. Negative 9 times negative 5 is 45. So I know that this works. Now I look at this, x squared minus 5. 5 isn't a perfect square. That's as far as I'm going to be able to factor that. What about x squared minus 9? That's the difference of squares again. So that factors down to x plus 3, x minus 3, times x squared minus 5. And one quick thing to check myself, the powers of x should add up to 4. We have 1, 1, and 2, so 1, 2, 4. Alright, so let's look at these next two examples. Figure out what's being squared so I can rewrite it in more of a quadratic form. Okay? Really, you just take the leading coefficient and divide it by 2. Right? Or, let's see here. So, what got squared to give me x to the 6th? Yeah, so this is the same thing as x cubed squared plus 6 times x cubed. Now there's not really a point in writing these parentheses around this. I just want to show you that it's different than just 6x now. Plus 5. So I need two numbers that multiply to 5 and add to 6. 5 and 1. Okay, so 5 and 1 multiply to 5 and add to 6. But instead of x plus 1 and x plus 5, this time we were dealing with x cubed, right? So this will be x cubed plus 1, x cubed plus 5. Alright, so now we have x cubed plus 5. 5 isn't a perfect cube. This isn't going to be a sum or difference of cubes. But 1 is a perfect cube, right? So now I gotta do my sum or difference of cubes. Sum of cubes says it'll be a plus b times a squared minus ab plus b squared. So this is going to break down into that. So what's a equal? What got cubed to give me x cubed? And just x. And my b is going to equal 1. So my answer will be x plus 1 times x squared minus x times 1 is x plus 1 squared, so 1, times x cubed plus 5. Alright, so for our last example, x to the 4th minus 81. What got squared to get x to the 4th? Yeah, x squared squared minus 81, right? So now, I picture this like it's just an x squared. So, is 81 a perfect square?
Yes.
Yeah, so this is difference of two squares. But instead of, we're used to writing x plus 9, x minus 9. Now we're going to write x squared plus 9 and x squared minus 9. Okay, x squared plus 9, there's no sum of perfect squares, so this is going to stay. But then x squared minus 9, this is the difference of squares. So what does that break down to? X plus 3 and x minus 3. And that's the completely factored version of that last problem.
So it's